Hello everyone, today my group will be covering the topic sound waves and explaining how a speaker produces sound. Our group is composed of Nilesh, me, Dunyathat, and Prem. To explain the parts, Nilesh will be doing a digital breakdown of a speaker.
Okay, so we'll be disassembling the speaker right here. The first part we'll take out of the speaker is the grill, which is put there to protect the speaker's cone while also allowing the speaker to produce quality sound. That's why the grill is made up of a mass material, or sometimes cloth even. So after you take out the grill, we can take out the next part, the speaker, which will be the case. And the thing with the case or the enclosure is its purpose is not just to protect the speaker from external forces or anything that could harm it and just give an aesthetic. Its purpose is also in the sound. The enclosure, the sound waves, it vibrates inside the enclosure and creates a more fuller or depth field of sound. And so when you're designing your speaker, you might want to have the sound case thought of before making the speaker. Next part for the speaker is the suspension. Suspension holds everything in the right place as the speaker is in action. And so this includes all the surrounding, all the pieces internally over here. And as the name suggests, it suspends the parts up there. Then we have the next part, which is the cone or the diaphragm, and this is one of the most important parts of the speaker. It's a component that produces sounds and delivers the results that all the other parts contribute to. So it amplifies all that sound, and it's a thin, semi-rigid membrane, and it vibrates to generate the sound. Then we have the basket or this casing over here. But the point of the casing or the basket is that it's responsible for holding all the parts of the speaker together, and so it's the framing, right? And the magnet, all the pieces, they're all put on towards the chassis or the basket. Then we have the magnet. This is known as the permanent magnet because the coil works as an electromagnet, and the magnetic field generated by this magnet differs based on the material used, but it always has the same purpose, which is to interact with the voice coil, which will be our next part. By generating attraction and repulsion, the magnet creates the motion of the loudspeaker in such a way, and that's why it's directly on the next part, which is called the voice coil, also divided into two. This is copper wire wrapped around, electricity is fed through, and this creates polarity, and this polarity makes it into an electromagnetic component, and this allows it to interact dynamically with this permanent magnet. And so the voice coil is basically known as the heart of the speaker because it's the main thing. As the current enters the voice coil, the magnetic field, the polarity changes, and the interaction with this magnet is what drives the conversion of the electrical energy into mechanical energy of vibrations into pushes and pulls on the cone over here, and this is what creates the sound that you hear. And so those are all the pieces, the basic pieces of a speaker. Some speakers have more pieces that generally serve the same purposes that these do. For example, creating a better infrastructure and holding other pieces together.
A speaker produces sound by converting electrical energy into mechanical energy, which in turn creates sound waves. This process involves a magnet, a voice coil, and a diaphragm. When an electrical current flows through the voice coil, it creates a magnetic field that interacts with the magnet. The voice coil is attached to the diaphragm, which is a thin, lightweight material that can vibrate in response to movement of the voice coil. The varying electrical current causes the voice coil to move back and forth rapidly, causing the diaphragm to vibrate and push air molecules, creating sound waves that travel through the air to the listener's ears. The frequency and amplitude of the sound waves are determined by the electrical signal being fed into the speaker. The intensity of the speaker sound can be described by the following equation. Beta equals to 10 to the base of log I over I initial. Beta is the unit of sound in decibel, which is 1/10 of the unit bell. The threshold intensity divided by the minimum audible intensity, which is 1 times 10 to the power of negative 12 watts per meter squared. The second equation is the same equation as the first one, but converted using the logarithmic rule, as shown here.
Three critical components of a speaker is the cone, speaker, and voice coil, and what changes does it make when those three components are altered. Larger cone typically produce more bass and lower frequencies. A stiffer spider can increase the speaker's power handling capability and improve its low frequency response, while a more flexible spider may allow for better high frequency responses and sensitivity. Increasing the size of the voice coil can improve the speaker's power handling capability and increase its sensitivity. Smaller voice coils may be more efficient at producing higher frequencies. The strength of the magnet in a speaker affects several aspects of a speaker's performance. A stronger magnet can provide more force to move the speaker cone back and forth, allowing the speaker to produce more sound at higher volumes, which increases its loudness. A stronger magnet can make a speaker more efficient, meaning that it can convert more of the electrical energy supplied to it into acoustic energy. A stronger magnet can help the speaker produce deeper bass notes, and a weaker magnet can result in higher levels of distortion. Pitch is the perpetual quality of sound related to the frequency of the sound wave. Sounds with a higher frequency are perceived as higher pitched, while sounds with lower frequencies are perceived as lower pitched. Loudness is the perceived intensity of a sound that is related to the amplitude of the sound wave. The larger the amplitude, the larger the sound. Loudness is measured in decibels. The quality of a sound wave is determined by the relative amplitudes of the harmonics present in the sound wave, as well as factors like the instrument or source of the sound. A speaker can produce a wide range of frequencies and pitches depending on its design capabilities. A high-quality speaker will produce a wide range of frequencies and pitches accurately without introducing distortion or coloration to the sound. The shape and material of the diaphragm, the size and shape of the enclosure, and the type and displacement of the drivers all play a role in determining the quality of the sound produced by the speaker. So what are the differences between speaker and earpod? Earpods are just small earbuds that fit directly into the ear canal, while speakers are larger devices that sit on a desk and can be mounted on a wall. Earpods are designed to deliver high-quality audio to the listener's ears, while speakers are designed to fill a room with sound. Speakers are generally more powerful and can produce a wider range of frequencies than earpods. How did they even shrink speakers to earpods anyways? Well, first they had to make electronic components much smaller and more efficient. They also needed high-performance materials that could deliver strong magnetic fields and good acoustic properties despite their small size. Signal processing algorithms and noise cancellation technologies were also developed to improve the sound quality of these small speakers. These advances allowed earpods to deliver a decent listening experience despite their small size. Overall, it took a combination of improved electronic components, advanced materials, and signal processing technologies to make earpods possible. And lastly, sound waves are vibrations that travel through a medium, like air or water, that can be heard by our ears. The speed at which these waves travel, called velocity, depends on the medium they travel through. The frequency of the sound wave is the number of vibration it makes in 1 second, and is measured in hertz. The physics formula that describes sound waves is V is equal to Fa, where V is the velocity of the wave, F is the frequency, and A is the wavelength.